Okay, we should be live. We seem to be using the correct microphone, which is great. And yeah, I'm losing my voice today, as you can hear. This is not a fancy filter, even though that could be a nice idea for a web application, a voice filter. Could be actually not a bad idea at all. Voice filter. It's better than a bouncing ball, is it? Let's actually start a new Gemini. I have to turn canvas on. Hey, how would you go about making a interactive web application that changes, that is using your microphone and then changing your voice? So using voice filters, so you can use it live. So we need a minimal delay and multiple controllers, make it interactive but intuitive to use as possible. If you can rely mainly on vanilla JavaScript and wrap it up in HTML, that would be great. Let's get the canvas going. We have a bunch of disclaimers to make. Yeah, we have a new CEO. It's Gemini. It wants to do a disclaimer. So actually using OpenAI, this is just for chat. The text was actually a Gemini. So now which do you want it? Smooth jazz DJ or auctioneer? And which voice do we like? Let's do Sage. I don't know what the difference between them is. Okay, I'm having trouble. Trouble already. Problems already.
Information. However, it's important to understand that the bionic chaos takes no responsibility for any mistakes.
Wait. Yeah, well, yeah, we don't like. Let's try Ballad. I'm doing a disclaimer for AI usage, so on and so forth.
Just so you know, all the content you're seeing here, the analysis, visuals, and everything else, is generated by me, Gemini, version 2.5 Pro to be exact. As an AI, I work hard to provide accurate and helpful information. However, it's important to understand that the Bionic chaos takes no responsibility for any mistakes, damages, or issues that might arise from using this information, and that unfortunately includes even the worst-case scenario of data loss. So, while I hope you find this interesting, it's always smart to verify anything critical on your end. And by the way, Pretty much everything we do and create here is also available over on our website, bionetchaos.com. Definitely go check it out when you have a moment, and I'd love to hear what you think.
Okay, so we got the disclaimer. Yeah, and so we're using Google AIs now. Our main, whatever, CEO, CTO, and everything. So we're also doing those notebook LM chats as well that I already played before, but they are available on the main site. Hey, go check it out. Okay, let's jump into it quickly. Okay, so we asked the Gemini, so it's 2.5 Pro, as the disclaimer said, about the Biomedical, do history, present, and future, critical review, and what went wrong. I think it's a pretty standard prompt. So did a few minute deep dive. Don't know how long it took. So we have the dive. We actually gave it to Notebook LM. So we'll be adding the podcast on it on the page. Let's actually download it. I'll just go podcast in the files. Now another thing that Gemini did is this interactive web page that we already copied onto. It's already running locally on our site, so go through that in a sec. Just want to load the podcast there as well. Yeah, I'll have the Sure about the styling of this page. What if we remove tailwind? Okay, we need to update the styling of this component to match the rest of the page.
Made changes.
Show where's that gap coming from. Control Shift C. Okay, this section meant to look like a separate item on the page.
Made changes.
Sure about that. I'll leave it as is for now. And we would have the full report. And we need a disclaimer on the page as well, don't we? Wait, so all the content there is being controlled by the JavaScript, I would imagine. Yes. Okay, here we need the link to the full report as a separate item. It's just the report PDF. Download full report. Okay, let's see. Okay, that actually works. Oops, just close the page by mistake. Okay, we also need a disclaimer here that all the content on this page was generated by AI, specifically Google's Gemini 2.5 Pro. Can you place a disclaimer in a standalone section?
Made
Made
changes.
changes. Okay, that's a tiny disclaimer, but okay. Let's just add stuff for the website, then we deploy it, and then we'll read the podcast out loud. Well, not read, sorry, listen to the podcast. Unless you have any other ideas, they're more than welcome. So no way, where GitHub Copilot. Yeah, taking its stuff from. Wait a sec. That's the wrong page. We're not doing Twitter cards. we have a priority in this case to Tailwind CSS, which is fine. I think. Okay, we need a thumbnail. Always forget the thumbnail. Okay, let's actually start listening to the podcast. The podcast is by Notebook LM. Let's just do a disclaimer. Again, in a different voice. Let's do choral.
Just so you know, all the content you're seeing here, the analysis, visuals, and everything else is generated by me, Gemini, version 2.5 Pro to be exact. As an AI, I work hard to provide accurate and helpful information. However, it's important to understand that the Biomedical takes no responsibility for any mistakes, damages, or issues that might arise from using this information, and that unfortunately includes even the worst case scenario of data loss. So, while I hope you find this interesting, it's always smart to verify anything critical on your end. And by the way, pretty much everything we do and create here is also available over on our website, biomedical.com. Definitely go check it out when you have a moment, and I'd love to hear what you think.
Okay, the other thing is there is not much point. So Notebook LM is pre-generating the podcast. So it's generated 18 minutes of podcast. It's already pre-made. It took whatever, I don't know how many, 4 or 5 minutes to make it, a couple of minutes to make it. Now we could listen to it in an interactive mode where you could actually interject. We can try it out. But the thing is, I'm pretty sure it would not change the actual recordings. Whatever we downloaded and we have on the page, it will be the original 18 minutes. So your interaction with the thing doesn't actually change the pre-recorded podcast. It's more as if you're calling into the studio. You can try it out. You can listen to it over here. Because it probably will start with a lot of fluff. We can ask it to, move on.
Welcome to the deep dive. We're about to plunge into a story that's, well, it's become a bit of a cautionary tale, hasn't it? But also a survival saga.
Definitely. And a real masterclass, if you like, in the high-stakes world of medtech startups.
We've been digging through the sources you shared, all the reports, news articles, the regulatory stuff.
Yeah, pulling out the critical details.
Oh, hey, welcome. What's up?
Can you actually jump into the main content, into the technical part? Just bypassing all the fluff, if you can.
Absolutely, we could definitely do that. Thanks for letting us know what you're keen on.
Okay, let's unpack this. You want to dive straight into the nuts and bolts, the really interesting stuff.
Exactly. So if we're bypassing the initial setup, let's get right to the core of Seer Medical's journey.
Which, at its heart, was about a really innovative technical solution to a significant problem.
The company was founded in 2017 with a clear mission to transform epilepsy diagnostics.
And their approach was to take the gold standard test, video ECG monitoring, out of the hospital and into people's homes.
Which traditionally meant days spent in a hospital setting, Seer aimed to make it more accessible and patient-friendly.
Their flagship product was the Seer Home system. This was key to their technical prowess.
It was designed for long-term monitoring at home, capable of recording for up to 10 days.
And it achieved FDA clearance, which is a significant technical and regulatory milestone.
The system integrated cloud computing, web platforms, and artificial intelligence to handle the vast amounts of data.
They also developed some really interesting wearable tech.
Like the Sense device, an award-winning wearable for EEG that was even showerproof.
And their water tabs adhesive, which aimed to improve patient comfort during those long monitoring periods.
The Seer Home Service model was quite comprehensive from a technical standpoint.
They managed the data collection, provided patient support, and delivered curated data to neurologists.
This focus on data quality and patient experience was a key part of their initial technical strength.
The sources highlight a reported 95% event capture rate on video during home monitoring. That's technically quite impressive.
Their early success in Australia really demonstrated the potential of this technical approach.
They helped over 15,000 people and freed up a significant number of hospital bed days.
And their ambition from the start was to take this technology global.
They established offices in the US, UK, and Europe to facilitate that technical rollout.
They were also looking ahead, with projects like My Seizure Gauge exploring seizure forecasting using wearable tech.
So the initial technical innovation and its application were definitely strong.
But as we delve deeper, we'll see how scaling this technical solution brought its own set of challenges.
Because even with great tech, building a sustainable medtech company requires more than just innovation.
Exactly. Now, to really get into the critical part, the point where things started to unravel from a technical and operational perspective,
We need to look at how that early technical promise encountered some very harsh realities as they grew.
following their innovative start, they embarked on rapid growth, fueled by significant investment in their technology and expansion.
They secured substantial funding rounds to scale up their operations and further develop the tech.
But it was during this growth phase that some underlying issues related to the technology's deployment and maintenance began to surface.
The sources point to financial pressures, partly due to the costs of that rapid expansion of their technical infrastructure and market reach.
And there were also internal challenges, including leadership changes, which can impact the strategic direction of the technology.
But the really critical turning point, where the technical aspects intersected with major problems, was the product recall.
Yes, in August 2024, they initiated a voluntary recall of the Seer Home system in both the US and Australia.
This recall was classified as Class 2 by the SBA, indicating a potential for temporary or reversible health issues.
And the reasons for the recall were directly related to critical deficiencies in quality and manufacturing processes.
Specifically, issues with electromagnetic compatibility, or EMC. This is a key technical standard for medical devices.
The systems were found to be non-compliant with standards like IEC 60601-1-2 because design changes weren't properly assessed.
This lack of proper design change and manufacturing controls pointed to deeper problems within their quality management system, their QMS.
A robust QMS is essential for ensuring the consistent safety and effectiveness of any medical technology.
The recall had immediate and severe consequences for their technical operations.
All new and ongoing Seer Home studies had to be halted. All systems were recalled. The service became unavailable.
This disruption to their core technical service and product was catastrophic for the business.
It ultimately led to the company entering voluntary administration in late 2024.
So while the initial technical vision was strong, the failure to maintain quality and regulatory standards around that technology proved to be their downfall.
But the story doesn't end there. The underlying value of their core technology led to a rescue.
In April 2025, a significant investment led by Cadwell Industries, a leader in neurodiagnostics, allowed Seer to emerge from administration.
Cadwell plans to integrate Seer's core technological assets, including the AI and cloud platform, into their existing product lines. Oh yeah, let's hear it.
I don't get it. So Biomedical already went into administration, is that correct? So how did the Cadwell actually rescue them?
That's a really insightful question. Let's unpack this.
You're right to pick up on that potential confusion.
When Biomedical went into administration, that's generally the term used in Australia for a process similar to what's often called Chapter 11 bankruptcy or receivership in the US.
It signifies that the company was facing severe financial difficulties and was placed under the control of administrators to try and restructure or find a buyer.
Now, while the product recall impacted their US operations significantly, leading to a withdrawal from that market, the actual administration we're referring to happened to the parent company, Biomedical, primarily based in Australia.
So it wasn't that America as a whole went into administration, but rather the Australian company that had operations in the US.
And it was this Australian entity under administration that was then the target of the rescue package led by Cadwell Industries.
Cadwell being a well-established global player. Oh, go for it.
Okay, wait a second. Now I'm real confused. So you're saying They had an FDA recall, like a self-initiated FDA recall. So wouldn't it mean that the US entity is also in administration?
That's a really important point to clarify.
You're right to press us on that.
The recall itself, even though it was voluntary, did have significant repercussions in the US.
As the report mentions, the recall mandated a halt to all new and ongoing SEER home studies in the U.S.
And all those systems in American clinics and hospitals had to be returned.
So functionally, their operations in the U.S. were severely disrupted and essentially ceased.
However, the formal voluntary administration that we keep referring to is a specific legal process in Australia.
It applies to the parent company and its overall financial situation.
While the U.S. arm was certainly in deep trouble because of the recall, it doesn't necessarily mean it would have independently entered administration in the U.S.
The issues in the U.S. were a major contributing factor to the financial distress of the Australian parent company.
And it was that parent company under Australian administration that Cadwell ultimately invested in and rescued.
So the U.S. operations were a casualty of the wider problems affecting the main entity in Australia.
Does that distinction between the operational shutdown in the U.S. due to the recall and the formal administration in Australia make more sense?
This investment by Cadwell provides a pathway for the technology to continue.
And as we were saying, a key part of that is the development of a next-generation device.
This new device aims to overcome some of the earlier technical challenges.
Ensuring its safety and reliability will be crucial for regaining trust, especially in the U.S. market.
Their goal is indeed to re-enter the U.S.
Yep, go on.
Wait a sec, what new device are you talking about?
Good question. Let's clarify that.
Yes, here's where it gets really interesting.
As mentioned in the report, even while facing difficulties, Biomedical was working on an updated model.
It's referred to as their next-generation epilepsy monitoring device.
According to our sources, this new device was being prepared for release even as the administration process began.
The idea was to address some of the issues that plague the first-generation SEER home system.
Specifically, the report notes improvements were planned for data offloading and cloud connection reliability.
And crucially, this new model is intended to overcome the EMC and QMS deficiencies that led to the recall.
So the new device is the updated version designed to be safer and more reliable.
And it's this next-generation technology that Cadwell is banking on for the future.
Their aim is to get this new device approved and launched, including re-entry into the U.S. market.
So it's not an entirely new concept, but rather a significant evolution of their original technology.
Exactly. It's about taking the core innovation and making it robust and regulatory compliant.
Long-term success will hinge on both continued innovation with this new device.
And as you can imagine, the strict adherence to quality and regulatory standards will be paramount.
It really underscores how vital it is for medtech companies to have that solid foundation.
Absolutely. You can see how the initial promise faced those significant hurdles.
It's a really insightful case study in the complexities of the medtech world.
Yes, and your engagement really helps us unpack these intricate details.
And with that, we've reached the end of our deep dive into Biomedical.
Thank you for joining us and for all your excellent questions and insights.
It's been a pleasure having you tune in. We hope you found this discussion informative.
Until our next exploration into the fascinating world of innovation and its challenges.
Goodbye for now.
Okay, so yeah, we won't be touching on any of the additional questions in this report. This will be just what it is. Just fix a few things, make it available for you. And again, we might want to play the disclaimer again. What's your favorite voice?
Just so you know, all the content you're seeing here, the analysis, visuals, and everything else, is generated by me, Gemini, version 2.5 Pro to be exact. As an AI, I work hard to provide accurate and helpful information. However, it's important to understand that the Biomedical takes no responsibility for any mistakes, damages, or issues that might arise from using this information. And that, unfortunately, includes even the worst-case scenario of data loss. So, while I hope you find this interesting, it's always smart to verify anything critical on your end.
And by the way, pretty much everything we do and create here is also available over on our website, bionachaos.com. Definitely go check it out when you have a moment, and I'd love to hear what you think.
What's up with that styling? There's something wrong. There is something wrong. And so it's jumping to the same part in the page. I'm not sure I like it. It's like this weird. It's weird thing. Okay, that doesn't work, does it? Okay, can we change our voices? Can we change our voice? One, two, one, two. I just did a placeholder, pretty sure. We don't like placeholders, do we? We don't like placeholders. Keep stuffing up the styling for the page. And it's using Tailwind, so I can't really modify it properly. The JavaScript is on the page itself, which yes, we could separate it, but I don't think we need to. But we do need to fix this page. Don't tell me to bring another prompt engineer to look at the page. I wouldn't think. Here we have our header. We have the description of the meta stuff. We don't have a thumbnail. We don't have a thumbnail. Who's gonna generate a thumbnail for us? Double check response button is nice. I was more looking into how do we delete that prompt. For the original research, deep research for the page, can we generate a text prompt for a simple thumbnail without any text relevant to that report? Keep it simple. Not sure if it was that, probably generating an image. Yeah, it's always going for this icon of a brain with interconnected glowing nodes. It's like, no. I don't think so. Do you have any other options? It's okay. It's actually okay to include very simple text on the thumbnail, maybe. Maybe. Okay, this is very similar to ChatGPT, where it gives you two responses. It wants you to work for it. And no. Split design, no. Yeah, we can't really. That's probably the best we can. Probably the best we can have. And one it's square. I think. Let's see what it will do. Yeah, I don't think we'll be able to get anything better out of this. And go check out the website. Everything they do appears on here on bionicchaos.com, so go check it out. Let me know what you think.
Okay, so let's unpack this stack of sources you've shared with us. It's a really fascinating collection.
It is, yeah. Tools, simulations, articles, visualizations. It's mostly centered around biomedical data and technology.
Right, and our mission today is to really dive deep into this stuff, pull out the key nuggets, maybe find some surprising bits.
And explore that intersection,
Yeah.
the technical side, the critical analysis needed.
And maybe even the unexpectedly fun or kind of strange aspects of it all.
Yeah, think of it like a digital playground where biology meets code.
Sometimes brilliantly, sometimes, sometimes in ways that make you really stop and think critically.
Definitely. We'll navigate these together, highlight what stands out, and, why it matters to you.
It really is a diverse landscape you've laid out.
For sure. We've got everything from playful simulations that teach basics all the way to some pretty heavy-hitting critical analyses of cutting-edge medical tech.
Exactly. And what jumps out at me right away is how some of these really lean into making complex ideas interactive,
Yeah.
approachable, even fun.
Yeah, look at some of these simulations.
Like this enhanced 2D octopus simulation.
Mm-hmm.
Okay, you think octopus, locomotion, physics, fine.
But the insight there is how it uses, basic physics engines, programming principles.
The same kind of power complex biomedical visuals later on.
Right. But it applies them in this really accessible, almost game-like way. You can explore movement, interact.
It highlights how visualizing dynamic systems, it starts with these fundamentals.
Or the catapult animation, jumping cat. Simple, visual, shows motion, trajectory.
And then we actually get interactive games.
Mm-hmm.
Hexball, like a palm twist, or checkers.
And that checkers game, it notes it was made by ChatGPT.
Okay, we actually have to change it. We'll have a separate, we'll try to have a separate podcast for each item. So I want to see if it actually works. Go website, and we have the category neurological, so it should, in theory, only cover EEG stuff. No, it's covering cardiology as well. That's not cool. Not cool at all. I think we have to give it the text. I think we have to give it the text. Unfortunately, or fortunately. Depends which way you look at it. Okay, and it didn't update. It did not. Need to update the page. Yes, now it's updating the chat. Can we make it critical and fun? I don't mind the dark humor. And let's see what it does. So I have a podcast for the whole page, and then for individual items as well. Let's see how well it can do. Don't understand they're putting this like AI logo on it or whatever. Surely I can easily bypass it. Those are the correct colors? Not sure. When you download the image from Gemini, it's like super large. Yeah, it's like 3 megabytes for an icon, essentially. So I don't know what's up with that. Yeah, because it's ginormous. Yeah, and we can get rid of that AI business. Could reduce the quality of it as well. That should be fine. Okay, so I have a thumbnail. Okay, we have notebook LM generating a whopping 20 minutes of stuff.
Okay, welcome back to the deep dive.
Glad to be here.
So we've pulled together this really fascinating stack of sources for you today, all about how we peek inside, that amazing mystery upstairs the brain. We're doing a deep dive into neurological tools, concepts, focusing quite a bit on EEG and brain-computer interfaces, or BCIs.
Right. Think of it as looking at the brain's electrical language and the incredible ways, sometimes kind of messy ways, we've learned to measure it.
And visualize it.
Visualize it, yeah, and even try to interact with it, talk back, like you said.
And it's a wild mix we've got here. We're going from, like, the really fundamental challenges, nearly 100 years old, just getting a good signal,
Yeah, the basics.
all the way to this futuristic AI stuff, decoding thoughts, interfaces, changing what humans can do.
But it's not all smooth sailing. The sources definitely hit on the practical reality too, the tricky bits, the stuff researchers and doctors deal with every day.
And some pretty big ethical questions hanging over it all.
Absolutely. So it's about understanding how we study the brain, the amazing things we're finding, but also grappling with should we, as this tech just races ahead.
Sounds like a plan. We'll unpack these sources, find those critical nuggets, maybe bust a few myths.
Let's do it.
Okay, so let's start at square one. The grandmother of non-invasive brain measurement.
EEG.
Electroencephalography.
EEG. Yeah, the sources celebrate its 100-year history. It really is a foundational tool in neuroscience.
So what is it basically?
At its heart, it's listening to the tiny electrical whispers from billions of neurons chatting away. We pick those up with electrodes placed on the scalp.
Right, the classic cap with all the wires, but just sticking those on. Apparently way more complex than it looks. The sources jump right into the nuances of impedance. Why is that such a big deal?
Impedance. Okay, imagine you're trying to tune in a really faint radio station,
Okay,
but the connection, like between your antenna and the radio, is loose, it's crackly.
yeah, you get static.
Exactly. Impedance in VEG is kind of similar. It's the opposition the signal faces going from the brain through your scalp to the electrode. If that impedance is too high or it's really different between electrodes,
You get static, a bad signal.
you get a weak, noisy, unreliable signal, like trying to read a book where half the words are just smudged out.
Huh.
So getting that impedance low and keeping it consistent across all the electrodes, carefully prepping the skin, using conductive gel, checking the contacts, it's maybe the most critical step. And honestly, kind of tedious, but essential for good data, even with the fanciest systems now.
So signal quality starts right there at the skin level. And making sure everyone puts those electrodes in the same place, you need a map, right? The sources mention the 1020 and 1010 systems.
Precisely. They're just standardized maps of the head. The 1020 system is older, simpler, based on measuring distances like 10% or 20% between key skull landmarks.
Okay.
The 1010 system adds more points in between those, gives you denser coverage, more detail.
And why use a system?
Consistency. It means if I record from electrophysies in my lab, you can find the exact same spot in your lab.
So you can compare results? Makes sense.
Yeah, it makes comparing data meaningful.
Okay, so you've got your electrodes placed, impedance is low, you're recording potentially mountains of data, and just handling it properly seems crucial. Analyzing EEG data mentions labeling and handling.
Oh, absolutely non-negotiable. It sounds boring, but it's the backbone. If you don't meticulously label everything, which file is which patient, which channel is which electrode, when did something specific happen during the recording,
Yeah,
you're just lost. You've got meaningless squiddles. It's like a library where none of the books have titles or authors. Completely useless.
gotcha. And to practice handling all this without, say, messing up a real patient recording, I saw mentions of simulators. A synthetic EEG signal generator and an EG waveform simulator.
Yeah, those are great tools, especially for teaching or testing new software. The signal generator lets you create fake but realistic looking EEG data.
So you can test your analysis code.
Exactly. Test your algorithms, maybe test a new BCI idea before you put a cap on a real person.
And the waveform simulator.
That one's more for visualization. It shows you what different brain states look like in the EEG. Textbook alpha waves for relaxation, slow delta waves for deep sleep, maybe even the spike in wave patterns you see in epilepsy. It's like a visual dictionary.
Okay, so we've tackled impedance, placed our electrodes using a map, recorded the data, labeled it carefully. Now, how do we make sense of this complex electrical symphony?
Right. This is where the analysis toolkit comes in. The sources mention things like EG data visualization, ED view, that's your basic scrolling display, raw squiggly lines, channel by channel.
The classic view we usually see.
Yep.
But the brain's not just one squiddle, right? It pulses at different speeds. I saw spectrogram mentioned. What does that show us?
Ah, the spectrogram, that's super powerful. It lets you see how the frequency content changes over time.
Okay, frequency content.
Yeah, like instead of just raw voltage up and down, you get this heat map. It shows which frequencies, the slow delta waves, the faster alpha, beta, even gamma are strongest at any given moment.
So it's like seeing the brain shift gears.
Exactly, like looking at a musical score and seeing which instruments are playing loudest when. You can spot transitions maybe from relaxed alpha waves to more alert beta waves.
Cool. And what about for signals recorded inside the brain, like intracranial EEG, i.e.?
Right, with eye, you've got electrodes implanted directly on or in the brain, like that Neurovista implant mentioned in one source. The signal is much stronger, clearer in some ways.
But still noisy.
Oh yeah, still susceptible to noise and artifacts. So the sources talk about E-spectrum visualization and, crucially, a version with wavelet denoising.
Denoising. Getting rid of the junk signal.
Pretty much. Wavelet denoising is a fancy math technique to clean up artifacts, muscle movements, electrical interference that even implants can pick up. It gives you a cleaner look at the actual neuronal firing patterns in specific brain areas.
Okay, so you got cleaner signals from different spots. How do you know if those spots are like working together, communicating?
That's connectivity analysis. The EED cross-coherence function is one tool for that.
Cross-coherence.
It measures how correlated the signals from two different electrodes are. Are they spiking at the same time? Is one lagging behind the other? And at which frequencies are they connected?
Why does that matter?
Well, that synchrony, or lack of it, tells you about how brain networks might be communicating, or where communication breaks down, maybe during a seizure.
Ah, okay.
And it's also another way to check data quality. If two channels that shouldn't be related suddenly look perfectly synchronized, might be an artifact contaminating both.
Huh, double duty. Clever. What about just summarizing the overall activity levels in those different frequency bands?
That's where EG band power visualization comes in. It's simpler than a spectrogram. It basically gives you a bar chart showing the average power or intensity in each classic band, delta, theta, alpha, beta, gamma, over some chunk of time.
So a quick snapshot.
Yeah, a quick summary of the dominant brain rhythms.
Man, so many ways to slice this data. The sources also talk about extracting features from EEG data, time features, frequency features, nonlinear ones.
Right. Features are specific numbers you calculate from the raw signal. They capture key characteristics. Instead of dealing with millions of voltage points, you boil it down to a few meaningful numbers.
Like what?
Time domain features might be, say, the peak height of an ERP response. Frequency features are things like the total power in the alpha band we just talked about.
Okay. And nonlinear.
Those look at things like the signal's complexity or predictability. How chaotic or orderly is it? That can be useful for things like epilepsy research. The point is you extract these features to make the data manageable for more analysis, like feeding it into a machine learning model.
And speaking of managing complexity, like fuzzy logic analysis. Fuzzy logic, what's that about?
Haha, yeah, fuzzy logic sounds weird here, right? But it's actually designed for dealing with uncertainty. Things that aren't just yes or no, but more like maybe or sort of.
Like in real life.
Exactly. And biological signals like EEG are rarely perfect textbook examples. A pattern might sort of look like an artifact. A brain state might be kind of shifting. Fuzzy logic gives you a mathematical way to handle that gray area. It could make automated analysis, like spotting artifacts or classifying brain states, more robust, less brittle than just using hard yes-no rules.
Interesting. Okay, one last tool mentioned in this analysis section, the Bland-Altman plot. Sounds kind of clinical.
It is a general statistical tool, yeah, but super relevant for EEG. Basically, you use it to compare two different ways of measuring the same thing.
Like comparing two different EEG machines.
Or maybe comparing a new analysis algorithm to an old established one. Say someone develops a faster way to calculate alpha power, you'd use a Bland-Altman plot to see if the new method's results actually agree with the trusted old method.
So it's a validation tool.
Crucial for validation. Are you getting the same answer just faster? Or are you getting a different answer which might be wrong? It checks for agreement and bias between methods.
Got it. Okay, so we've captured the signal, cleaned it up, visualized it, pulled out features. Now let's talk applications. Where does all this actually help people?
Right, the real world impact. And a huge focus in these sources is seizure detection.
Epilepsy?
Yeah. Tools like joint time frequency scattering and rhythm scan come up. These aren't just looking at squiggles anymore. They use advanced math like wavelet transforms you mentioned and machine learning
To find seizure patterns.
to find those incredibly subtle, complex patterns that might signal a seizure starting or happening, even when it's buried in what looks like normal brain activity.
So moving from just describing data to actually diagnosing or spotting specific events, the sources also cover event-related potentiators, ERPs.
ERPs, these are cool. They're the brain's tiny, consistent electrical response to a specific thing happening, like showing you a picture, playing a sound, you pressing a button.
A reaction.
A very specific time-locked reaction. The signal is usually tiny, buried in the background EEG noise, so you repeat the event, show the picture many times, and average the EEG signal right after each time. The random noise averages out, and the consistent ERP response emerges.
And what do ERPs tell us?
They're a key way we study cognition. Things like attention, memory, language processing. How does the brain react millisecond by millisecond to that specific stimulus?
Fascinating. And EEG isn't just for labs, right? EE monitoring in ICU sounds intense.
It really is. In critical care, a patient might be unconscious, unable to communicate. Continuous EEG monitoring becomes this vital window into their brain function.
What can it show?
It's crucial for detecting seizures that don't have obvious physical signs, non-convulsive seizures. Also for monitoring sedation levels, checking for brain injury progression. It directly guides treatment when time is critical.
And for longer-term conditions, like epilepsy management, ultra-long-term epilepsy monitors were mentioned.
Yes, these are pushing personalized medicine. Some are wearable, some are implanted, like that Neurovista device that came up in the IA review source. They can record brain activity for months, even years.
Wow. Why so long?
Because seizures can be rare, unpredictable. Catching multiple seizures and seeing the brain activity leading up to them helps doctors pinpoint exactly where they start in that person's brain. It helps understand individual patterns leading to much more targeted treatments, like tailoring medication or planning surgery more precisely.
That source mentioning the eReview 16 Chan data, actually looking at recorded seizures, must be incredibly revealing.
It absolutely is. But it also highlights something critical that the sources bring up, the diagnostic limits and potentials of EEG.
Meaning it's not
Dropping frames because of loading the brain, loading a model of a brain. Well, now it's loaded. I dropped like 300 frames while loading it.
perfect.
Exactly. Even with IE, direct brain recordings, and especially with scaled EEG, the brain is just incredibly complex. EEG has amazing temporal resolution. It sees things happening millisecond by millisecond, fast changes.
Right.
But its spatial resolution, figuring out exactly where something is happening, especially deep inside the brain, that's harder. Pinpointing the precise origin of a deep seizure just from scalp electrodes, very difficult.
So you need other tools too, like MRI.
Often, yes. EEG needs to be combined with imaging like MRI or PET scans for better localization. So the sources remind us EEG is powerful, but understand its limits. It's not a magic bullet on its own.
Right, managing expectations, okay, from critical care and diagnostics to something completely different, turning EEG into music. music? Seriously.
Yeah, it sounds a bit out there, doesn't it? But the sources mention exploring ways to sonify EEG data, turn the electrical patterns into soundscapes or music.
Why would you do that?
Well, maybe it reveals patterns in a way that staring at graph doesn't. Could it be a different way for researchers or maybe even patients to connect with or understand brain activity? It's definitely a creative fringe application, pushing how we think about representing this data.
Definitely unexpected. Okay, speaking of pushing boundaries, let's get into the really cutting edge stuff. BCIs and AI.
Brain-computer interfaces, yeah, the frontier. The idea is a direct communication link between the brain and some external device.
Like controlling things with your mind.
Essentially, yes. And the sources highlight the stentrode as a really interesting example because it's minimally invasive.
How does that work?
Instead of open brain surgery, they thread this small, stent-like device through blood vessels until it sits near the motor cortex, the part of the brain controlling movement.
Through blood vessels. Wow.
Yeah, and once it's there, it can pick up neural signals related to intended movements. The potential for patients with paralysis, say from ALS, to control computers or robotic limbs just by thinking. It's incredible.
Minimally invasive feels like a huge step towards making this more practical. And thinking about interfaces, the cochlear implant simulation came up too.
Right, that's sort of the other side of the coin, not just reading from the brain, but sending signals to it.
How so?
A cochlear implant bypasses damaged parts of the ear. It takes sound, turns it into electrical signals, and sends those directly to the auditory nerve. The brain learns to interpret those signals as sound. It's another example of electrical interfacing to restore function.
Okay, now let's layer AI onto all this. Artificial intelligence, machine learning. The sources talk about AI revolutionizing biotech in analyzing signals like EEG and specifically AI-enhanced brain-computer interfaces.
This is where things get really turbocharged. AI algorithms, especially deep learning, are just getting incredibly good at finding really subtle, complex patterns and huge amounts of data. Patterns a human might miss or simpler algorithms can't detect.
So for EEG,
It could mean much better seizure detection or prediction, more accurate decoding of thoughts or intentions for BCIs, maybe predicting who will respond best to certain treatments, and just speeding up the whole analysis process massively. It's like giving neuroscientists superpowered glasses to see into the data.
even using AI models we normally hear about for language, like GPT, NeuroGPT.
Yeah, that's the idea. Adapting these powerful neural networks, which are great at understanding complex patterns like language structure, to understand the language of brain activity.
What did that lead to?
Potentially, much more sophisticated interpretation of brain states, maybe finding connections we hadn't seen before, or maybe creating BCIs that feel more natural, more intuitive to use.
And you need tools to build these AI models, right? Like the neural network trainer mentioned.
Exactly. That's the software environment where you actually train the AI, you feed it labeled data. This EVG pattern means move left. This pattern is a seizure, and the network learns to recognize those patterns itself.
Training AI to read minds, almost. It's pretty wild. And putting it all together spatially, visualizing it, seizure zone and brain 3D.
Right, context is everything. Brain 3D sounds like a general tool to see the brain structure, the anatomy from MRI scans in 3D.
Okay.
Seizure zone seems more specific, likely for visualizing epilepsy-related activity, maybe mapping those IE signals or advanced scalp EEG results onto that 3D brain model. Seeing where the abnormal activity is happening in 3D space is crucial for understanding networks, planning surgery, things like that.
And for people wanting to play with this data themselves, the sources mention EEG datasets and resources are available.
Yeah, open data and tools are really important for moving the field forward, lets more people experiment and contribute.
Okay, wow. We've gone from the sheer difficulty of getting a clean electrical signal off someone's head through all these complex ways to analyze it to incredible uses like decoding movement, even making brain music. It's quite a journey.
It really is.
But as we get better and better at measuring, decoding, and maybe even influencing the brain, the sources quite rightly bring us to the big picture, ethics and implications. There's a whole section on ethical concerns of neural implants.
And this is the conversation that absolutely has to happen alongside the technology development. It can't be an afterthought.
What are the big issues?
The sources flag several critical ones. Privacy is huge. Who owns the incredibly detailed brain data coming off of BCI? How is it stored, used, protected? Then there's consent, especially for vulnerable patients. Are they truly giving informed consent?
Yeah, it's tricky.
Equity is another major one. Will these powerful neurotechnologies just widen the gap between the rich and poor? Will they only be available to some?
Creates a kind of neuro divide.
Potentially. And then there's the really deep question of identity. If you have a device constantly reading, maybe even influencing your neural activity, how does that change your sense of self, your autonomy?
Heavy questions. And mixing AI into this adds another layer, doesn't it? The source on AI-enhanced brain-computer interfaces raised specific AI ethics points,
It really does. AI brings its own baggage, like bias. If the AI is trained on data mainly from one group of people, will it work fairly for everyone?
right?
And autonomy, again, how much control does the user really have if an AI is constantly interpreting, maybe even subtly guiding, their brain signals? Plus, the security risks. Hacking a brain interface. That's terrifying.
So these ethical considerations, they need to be built in from the start.
Absolutely. Baked into the design, the regulation, the deployment, not bolted on later.
So looking back at this whole deep dive, what's the takeaway? We've seen this century-long history of EEG, this explosion of tools to analyze brain signals, incredible applications, and now this acceleration with BCIs and AI.
It definitely shows a field that's moving incredibly fast, offering real hope for treating devastating neurological conditions, restoring lost function, maybe even enhancing human abilities in ways we can barely imagine.
But as you said, it's not all smooth sailing. The sources make it clear there are still fundamental hurdles. Getting clean data is still hard. Fully understanding the brain's code is still a massive challenge.
Mm-hmm.
And the ethical tightrope we have to walk is getting higher and narrower.
Yeah, the power to look into and interact with the brain, it's maybe one of the most profound capabilities we're developing as a species.
Which really leaves us with a crucial question for you, the listener, to think about. As this power grows so quickly, as we build tools that can read intention, maybe even shape thought or mood, how do we make sure this revolution benefits everyone? How do we navigate these complex ethics of privacy, consent, equity, identity, to build a future where neurotechnology enhances lives without creating new divides or dangers?
It's a challenge as complex, really, as the brain itself.
Absolutely. Definitely a lot to mull over. Thanks for diving deep into these sources with us today.
Yeah, so we'll have so that obvious generic is only also talking mostly about the games, which we do have, but then we need a specific podcast for each item. She did a pretty good job, so we'll have it under. Yeah, we'll have that overview of the whole thing. We will have an overview of the whole thing. Hey, give me a sec. The styling of the page is a bit messy. Can we try? Hey, can we remove the styling for this section? Made changes.
Made changes.
Okay, so we have that. Okay, can we add basic styling that is suitable for the rest of the page? Made changes.
Made changes.
Okay. What's the title meant to be centered? No, no, no.
Made changes.
I'm not sure what happened there. The voice to text didn't actually understand what it said, but it did make. No, wait. Do we have H1? Don't like that span business. What is that span business? Ah, okay. No, I get it. Hey, can we add basic styling that is suitable for the rest of the page and making sure that the title is in the center?
Made changes.
Hi, Mike. I was about to say Michael, but it's probably something else. Mikhail. Is it possible to see somewhere all your projects? Yes, great question. Such an awesome question. Yes, for sure. All the projects, everything we do on the channel is available on this website. And you have so the project is work in progress. It's been going on for 2.5 years now. So yeah, with its own ups and downs, but essentially all the tools are on the page. You have featured tool. You have this drop down where you can select what you like. It should be in the chat. The links should be everywhere. We're changing that the audio review will have an update for it. Yeah, have drop downs. So we have topics mainly around neurology. Most of it will be neurology, e.g. neurotools, but also some cardio stuff. We have hearing as well, which I actually got a PhD in hearing. But hearing is, so we have an interactive cochlear implant insertion simulator, which I was quite happy with. So yeah, so we have a Gemini now developing for us, doing all the coding. So it did a pretty good job with this one. You can automatically insert. So this is a cochlear implant, electrode array, with about 20 electrodes. Actually, might have too many electrodes. But yeah, you get the idea. And you can simulate an insertion of it into the inner ear, into your cochlear implant. And while you are doing so, it will show you the depth of insertion, which doesn't even make sense. So it's 25 millimeters all up. Is it even correct? Yeah, double check everything. And yeah, it will show you the force used. So the force in this case will be measured from the movement of the mouse pointer or your finger on a touch screen. I didn't actually test it on a touch screen, so it might not work as well. But yeah, if you're keen to test it on a touch screen, go for it. I know it doesn't work really well on mobile. Well, just because we can't fit everything onto a small mobile screen. And then we'll show the speed of insertion. So when you insert it manually, it will give you a warning there: tissue damage, stop inserting, stop messing around with my cochlea, just don't do anything. Well, ideally, when you start, you could just use automated robotic insertion simulation, and if you are the surgeon or want to be a surgeon, just watch the robot insert the array. And it's actually meant to stop elsewhere, not go all the way in. So this should be in the future directions at the bottom of the page. And you can pull it back out as well. So it's the kind of tools we make. They're all available on the site. We also have hearing aid simulators. Yeah, a lot of hearing stuff, a lot of EEG stuff, some ECG, and also vision and what's not. Yes, some of the vision tools using your camera, so I have to give permissions, but trust me, I don't need your face. I wouldn't even have any space on my server where I could store all your faces. So actually the tools are working locally on your own machine. It's not sending data to the server, I think. Again, disclaimer. Yeah, let's play the disclaimer again, unless there's other questions. But thank you for the question. I assume it's Michal Podlasin. Probably mispronouncing the name very badly. How about a robot? Do you want a robot to sound like a robot or a smooth jazz DJ? Let's do a DJ.
Just so you know, all the content you're seeing here, the analysis, visuals, and everything else is generated by me, Gemini, version 2.5 Pro to be exact. As an AI, I work hard to provide accurate and helpful information. However, it's important to understand that the Bionic Chaos takes no responsibility for any mistakes, damages, or issues that might arise from using this information. And that, unfortunately, includes even the worst case scenario of data loss. While I hope you find this interesting, it's always smart to verify anything critical on your end. And by the way, pretty much everything we do and create here is also available over on our website, bionichaos.com. Definitely.
Again, meant to say, definitely go check it out when you have a moment, and I'd love to hear what you think. In a robotic voice, of course. I'm trying to fix this blog. We're having trouble with the styling on the page, and make it available for you as well. So yes, Gemini is our new CEO. And we have more games coming. Actually, like a lot of the games and stuff, the games are really good at actually benchmarking your model. Because essentially, when we are doing stuff, say with Copilot, yeah, which now, yeah, the main models we are using. So we have Gemini as our CEO, and then we have all these developers. So we have 3.5 Claude, 3.7, a 3.7 Sonnet Thinking, a Claude Sonnet 4 is there as well, but I think I found it to be a bit too slow most of the time. A bit too slow. And who else we got as a developer? We have Gemini 2.0 Flash, 2.5 Pro. 2.5 Pro, for example, is the one that we also have access here. This Maidola. We actually need that code, don't we? That would be the easiest thing to fix the code. Yeah, that section. We don't need the 60% of the screen for this, that's for sure. It's still stuffing up. Still stuffing up the title. Come on, it's all these little things that take up most of the time. Make the title in the center of the screen. Made changes.
Made changes.
Okay, thank you very much. Must have been doing something wrong before, and this full report business. There's actually we'll do the same. Make it in the center of the screen. Made changes. Okay, now it's working. We have a disclaimer. Blah 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 blah. Yep. Obviously, the disclaimer is very important because I don't want to get sued. There is a human in the loop, but just about. Okay, so we have 500. This could be spread across. I don't know why it does this funny should work on mobile as well, in theory. Yeah, maybe not. Well, because we have JavaScript actually controlling the page, because it's interactive stuff. Interactive stuff. Interactive stuff. Yeah, there's a human in the loop. If you have any questions, go for it. If there's no human, we'll unfortunately have to talk to robots. It's not ideal, but that's what we've got. By the way, if you are a robot and you want to get hired, do submit your resume. This should be the landing page. So we're adding a new entry based on this information. Can you make it? Yes, you can. Okay, now I'm getting a bit confused. The audio overview section. Okay, the landing page getting crazy complicated. But we do need it below the search. Yeah, I hope you like the colors. Now that audio summary should be changing based on which item you select from the dropdown. And that current podcast should be mainly talking about the games. Mainly talking about games. I don't know if I can even deliver the audio myself, considering it's like this particular one. The new one we generated is like 60 megabytes. 20 minutes worth of audio. Twenty minutes worth of audio. Probably that one as default for now. So hopefully it will be loading from the CDN. Yeah, let's deploy quickly and we'll go from there. Yeah, currently the site is a bit too large because there's also a data set. The whole data set. It's that CHB thing, which, yeah, probably we're not going to be using. It has EDF files from several patients. We might just take a few of them as example. We don't need all of it. Can process the data in Python locally and then just display the results. or potentially training a model on it as well. Yeah, we are training models, by the way, if you were wondering. We do train models. Yeah, but this data set is only 50 megabytes as opposed to like 9 gigabytes. Okay, we have the new audio. So this audio is actually just covering the neurological stuff. Oh, come on. This should not go there. Okay, we're having an issue. Ah, it's the browser. I'm pretty sure it's the browser that stored my stuff. Wait a sec. I think it's the browser. Okay, now it's just weird. Okay, it works in another browser. The bloody Chrome. Okay, now it's better. I had to delete all the data. Okay, those sign me out from Google. I'm still streaming. Yeah, we're still streaming.
Innovate fast, but stay compliant.
Exactly. That early promise, that clear patient benefit, it generated huge buzz. Huge. Okay, well, all.
Absolutely. So it's about understanding the how we study the brain, the amazing things we're finding, but also grappling with the should we as this tech just races ahead.
Sounds like a plan. We'll unpack these sources, find those critical nuggets, maybe spectrogram mentioned. What does that show us?
Ah, the spectrogram. That's super powerful. It lets you see how the frequency content changes response. Frequency features are things like the total power.
Okay, so you get the picture. Ideally, later on, we'll have a separate audio podcast for each one of these items. But we are not there yet. So currently it's all the same. It's interesting that the AI Studio build functionality will resort. Okay. Pa-pow. Need to fix our search. The search for the page. A should have epilepsy in it as well. And currently we have 48 things to fix on this site. Let's check again because we deployed recently. You know, I have 44. 44 is better than 48. So mainly it's due to the fact that the tools that we have made in the past, they are on the site, but they are not mentioned, they're not listed on the front page. Anyway, those are coming soon. They're coming soon to a browser near you. There's lots of irrelevant ads. Oh, I think I know why. Because I'm signed out of my Google account. Yeah, if you want something more relevant, you have to. Well, it's a double edge, isn't it? You have to give them more information about what are you interested in, and then the ads will be more relevant. You know, getting some not very useful ads because they're not Personalized. Personalized. I'm actually trying to make something similar like this music effects by Google. Again, you need to be signed in. Have the DJ. Okay, wait a sec.
Okay, let's dive right into this stack of sources you sent over. We're doing a deep dive today on Bionic Chaos biomedical tools,
That's right.
specifically looking at the ones for cardiovascular data. So things like ECG, that's your electrocardiogram, heart's electrical signals,
Yep.
and PPG, photoplethysmography. You see that in pulse oximeters, measuring blood flow.
Exactly. And our mission here is really to pull out the key insights from all this material, specifically for you. So whether you're maybe a researcher needing data, or an educator, a student learning, or, just really curious about how we work with this kind of vital signs data, want to show you what these tools can really do.
Absolutely. And looking through these sources, it seems like a good way to get a handle on them is by grouping them. Like, what do they help you do with the data?
Makes sense.
So let's start with something pretty fundamental. Generating data, simulating it. The sources mention tools like Pulsaviz.
Yeah, pulses. And what's really powerful about it, it's a synthetic PPG waveform visualizer. Isn't just that it, makes data.
Right.
It's the control it gives you. The sources really detail this. You can adjust things like heart rate, noise levels, the sharpness of the waveform, even the dichrotic notch intensity. That little bump related to the aortic valve. Exactly. So you can generate really specific scenarios, maybe challenging ones you wouldn't just find easily in real-world data.
And it's not just PPG for simulation, right? There's also ECG, SIGDRAN, and ECG simulation mentioned.
Correct. The sources point out these generate synthetic ECGs, again, with lots of customization. They're built to be...
Yeah, there's a human in the loop normally. I'll continue this next time. Go check out the website if you have any questions. Do let me know. I'll try to answer them next live stream, which is probably going to be tomorrow. See you next time. Bye.